All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we're still doing our malaria precision recall accuracy module. Let's have a look at what we went over today. Now, yesterday, we started the topic of talking about where we at here, the AUC, which is the area under the curve. And today, we're going to pick up where we left off. Now, I'm going to move to the area under the curve. For the area under the curve, we generally use this when we are comparing two models. So let's call our first model, model alpha. This is going to be our model alpha here. Let me move down so you can see it. You can see here, this line here, this will be our model alpha. Then we will have a model beta. Let me move down so you can see our model beta. This will be our model beta here that curves, goes up and it curves in. That's our beta model here. So we have an alpha model that goes straight up or diagonally up. And then we have our beta model that goes up and it curves over. Then we have a model beta. I showed you that already. Let me go down. It's clear that model beta is better because it gives us better options. Now we'll see that if we find ourselves there, we get a better true positive rate, false positive rate balance as compared to when we find ourselves at a position with the model alpha. So let me show you what that looks like. So let's say we had a position here within our model beta. You can see we are very close to the true positive rates. And then if we trace our way all the way down, have a very low false positive rate. As opposed to having a position here in our alpha model, we would have an okay position for a true positive rate. It's not the highest we can be. You can see we'd have a higher true positive rate in beta, and it's not the lowest we can get if we came straight down. Our false positive rate, we can get low or beta. So that's why I'm saying our model beta will perform our alpha model. So if we are comparing these two models, we can make use of the area under the curve by calculating this area covered under the curve of model alpha. So let's go ahead and bound this, and then for alpha, we have this area under the curve, popularly known as the AUC, with the lowercase u. So this would be the area under the curve of the model alpha here. All of these lines coming down cover the entire area of the model alpha under the curve of alpha. So that would be our AUC for alpha. All of this here, all of these lines that what do you call that there? All of these lines that indicate that this is the area under the model alpha, the AUC. And then for beta, we will have this area under the curve. Let me take that out of there. That doesn't belong there, which covers the area under the model beta plus the area under the model A. So with the model beta, you can see we have our area under the curve of beta here. Will be these lines designating this the area of the model beta, but then also it would encompass all of the area under the C also, or under the alpha also, because it's going straight down. So it'll be counted as not count. I guess it will be counted as one big area under the curve of beta, but it is separated because alpha does has its own area under the curve, but beta does encompass its own area under the curve, but then it encompasses alpha also. But as you can see, it's all in one model. So, well, it's all in one ROC, not one model. There are two different models in the ROC, but beta would encompass both of them inside of the ROC. And so, in general, we have two models, and then we want to compare them. We could use the area under the curve since it shows us how much freedom we have in playing around with the thresholds. We're gonna leave it there for now because we were gonna start writing some code, but I didn't want to start writing it as of now. We will start that tomorrow. I just wanted to focus on ROC and getting the area under the curves down packed. Make sure I understood what was going on with that completely. Since we have that down packed, we can move forward, and we will do that tomorrow. Of course, I will keep you guys posted every step of the way. For now, it's Python Poppy. You guys stay Gucci.